Hello students, welcome to another interesting lesson. Today we'll be looking at the Earth's movement, rotation and its effects. The Earth that we dwell on is a very large planet. It has a surface area of 443 million square, and the Earth has an equatorial circumference of 48,085 kilometers. The Earth has an equatorial diameter of 12,762 kilometers and a polar circumference of 39,155 kilometers. It also has a polar diameter of 12,722 kilometers. The Earth rotates from the west to the east. Look at this video, you can see the way the Earth is rotating, and it does this in under 24 hours because of the speed. It's permanently inclined at an angle of 66.5 degrees to the plane of its orbit. It rotates around its axis once. Just look at the way it rotates. It is usually faster than this, but thank God for Geographic Information System, we're able to get this clip from space. Like I told you earlier, it has an equatorial circumference of 48,085 kilometers. In this lesson, we'll be knowing why the Earth rotates, its effects, and how they occur generally. This movement of the Earth is something that there is a difference between rotation and revolution, though, because revolution takes 365 and quarter days to have a complete one, while the rotation just takes 24 hours. Now you see the surface of the Earth, like we discussed in our previous video, that is spherical in shape, and you can see from this picture how it looks. Although we couldn't get something concise, but thank God for GIS. Like I said earlier, it helps us to know. The rotation of the Earth is the movement of the Earth. Like I said, it spins in a west to east direction once every 24 hours, and that's what we call days. When you say tomorrow, next tomorrow, everything is just under 24 hours. Each 24 hours makes a day. I'm sure we all know that earlier. The sun and the moon have a very great role to perform in the Earth's rotation and their effects. And you know, generally, the planet Earth rotates around the sun. Not just planet Earth, all planets rotate around the sun. You can see another picture of the rotation. That is from, we have the North Pole, the South Pole, and the direction in which it's rotating. It's a planet, it rotates around the sun. The sun is the source of light and energy, like we discussed in our previous video. And then we also know that a satellite revolves around the planet. And like we said in our previous video, the moon is the natural satellite for planet Earth. So now back to our rotation. We'll be finding out in this lesson what happens when the Earth rotates, why it rotates, what the rotation is about, and why we have different time zones, most especially. So without wasting time, let's dig deep into the Earth's rotation, the effects. Number one, the rotation of the Earth causes day and night. How does this happen? It's very simple. Like I told you earlier, the Earth rotates around the sun. All planets rotate around the sun. So, and a satellite rotates around a planet. From this picture, you can see the sun. You can see the part facing the sun. That is what they call day. And the part that is in darkness at that moment, that is what you call night. We have different countries and different time zones because of the rotation of the Earth. You know, when the Earth rotates, you can see sometimes in the clouds, you can observe little movements, especially when it's about to rain or something. All those we'll discuss in another lesson. But right now, I'm just focusing on the effects of the rotation. You can see the part facing the sun is called day, and the part that is away from the sun will be dark. That is what we call night. It causes different time zone, and you can have your time. Some people may be in day, and some people will still be in night. That is the effect of rotation. Secondly, the direction of rotation affects the way we see heavenly bodies. You know, when the Earth rotates, you can see the sun moving across the sky. Sometimes we have late suns, sometimes we have evening suns, but all those happen in rare condition. We often say that the sun is rising or setting, but actually it's the Earth rotation that gives us that view, because the sun is just in one place. Like I told you earlier, pay attention that the Earth is a planet and all planets rotate around the sun. So when you feel it like the sun is setting or the sun is going down in the evening, it does not mean the sun is moving. You can see from this picture, it's not that the sun is moving. Illustrating over there on the top, you can see that the Earth is the one moving around the sun, and at a very fast speed. It takes you just 24 hours to complete its rotation. You can see the North Pole, the South Pole, and you can see the angle that is inclined at. There's an equatorial diameter, and it's permanently inclined on 66.5 degree, meaning it's not just straight. You can see it's looking like something that is slanted. If you check your mathematics and you use your mathematical set to draw a complete circle, you would understand you can get the angle in which it is inclined at. Now we'll be looking at another effect of the rotation of the Earth. Thirdly, the rotation of the Earth affects the velocity of objects located on the Earth, because it rotates at a speed, and all the objects vary from the equator to the poles, because the Earth rotates through 360 degrees. Remember, it's inclined at a 66.5 degree, but it rotates through 360 degrees in 24 hours. And the Earth's speed is 17,000 kilometers per hour. Imagine a car going at that fast speed. The highest a car can go for sport cars, maybe 320 kilometers per hour. No car has ever been able to go 1,000 kilometers per hour. So just imagine how fast it is the Earth rotates. Another effect is that the rotation of the Earth causes objects which are moving on the Earth's surface to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection is known as Coriolis defect. Coriolis effect is simply the objects being declined to the right on the northern hemisphere and to the left in the southern hemisphere. Just in case someone asks you what is Coriolis effect, that is what it's about. Now, without wasting time, look at how it happens. When the Earth is rotating on the other side in the northern hemisphere, you know your cardinal points, the north is up and the south is down. Objects are deflected to the right while it's rotating, while those on the southern hemisphere, the objects are being deflected to the left. It is just because of the Earth's rotation and the speed that causes these effects. And in case anyone tells you, like, what do you know about the Coriolis effect? This is what the Coriolis effect is just about. It causes objects to be inclined, and that's another effect of Earth rotation. And then we should have in mind that when the Earth rotates, objects on it, they don't tend to fall off or feel it because of the gravitational force. We said that in our previous lesson when we're talking about the size and shape of the Earth. Now, another effect is that the Earth rotation causes different regions to have different time zones. Like we said earlier in the beginning, when the Earth move away from the sun, the parts facing the sun experience sunlight, while the parts not facing the sun experience darkness. Now you can see why are there time zones? Because when the Earth different places would either be in daytime or nighttime. So if you in Lagos, you are in the afternoon, someone in Canada can still be in night, because the part facing the sun is the part that experiences daylight. So not just Nigeria, West African countries and like the UK, they share the same time zone with Nigeria. We're all placed on that part. You can see from the map of the world and the 7 continents when you see Africa, Asia, and so on and so forth. So it depends on where your country is located. That indicates the time zone. So look at the sun rays and look at the latitude. We'll be talking on longitude and latitude in our later lessons, but for now, we're still just being focused on the rotation and its effects. So, from everything you've learned so far, it has effects. The sun and the moon play a great role. The moon reflects because of the energy it has acquired from the sun during daytime. So that is why when it becomes dark, the moon is a natural satellite that helps also as a source of light in most cases. It takes the moon 28 days to rotate around the earth to have a complete revolution. I'm sure you enjoyed this lesson, and I will see you in the next lesson. And before then, always remember to drink water and don't pollute the environment. Stay cool and have a lovely weekend.